Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called routing oranges. So in this problem, we have been given a grade and each cell of the grade can have one of three values. Value 0, 1 and 2. 0 represents an empty cell, value 1 represents a fresh orange, value 2 represents a rotten orange. Okay. So the scenario here is every minute a fresh orange that is adjacent to a rotten orange becomes rotten. Okay. And we need to find the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, let's go ahead and return -1. Let's try to understand this problem from here, from the whiteboard. Okay, so this is the rotten orange here. This is the rotten orange, first rotten orange. What it will do, it will check like 4 directionally, up, down, left and right. Right, so these are the directions like up, down, left and right. Right, so it will go right hand side. It found the fresh orange, it will become, this fresh orange will become as a rotten orange. It will go down, this fresh orange will also become as a rotten orange. It cannot go left side because it cannot go outside of the matrix, right? It cannot go above side because it again cannot go up above, I mean outside of the matrix, right? Above means like it cannot cross the boundary of the matrix. All right, so the other two neighbors oranges basically also became as a rotten because of this rotten orange, right? Now these rotten oranges will impact other fresh orange as well. So let's see, this orange will make this orange as a rotten. If it will go down, there is like empty cell, right? It is, this value is 0. This grid cell value is a 0. 0 means empty as per the problem statement here, right? All right, so it will make this orange as a rotten, and what this orange will do, it will make this orange as a rotten, right? So now we found this situation here. Now this orange will make this orange as a rotten. If we'll go right, there is a that is a empty cell, right? Not fresh, but it is an empty cell. So empty cell, it cannot make anything, make any difference in the empty cell because there is no orange here. If it will go up, there is already rotten orange. If it will go left, it's already rotten orange, right? So it cannot make rotten orange again as a rotten. It will only impact, it will only make fresh orange as a rotten, right? And now this rotten orange will make this orange as a rotten as well. If it will go up, it's already rotten. If it will go left, it's already empty cell, it will not do anything. It will go down, it cannot go down because it cannot cross the boundary of the matrix. All right, so at the minute 4 we found this situation. Now let's consider for a minute rotten orange as a node in the matrix or in the graph, and this node is visiting all the eligible neighbors, right? So if one node is covering or visiting all the neighbors, and then similarly we follow the same process, this strategy is called the breadth first search in the graph traversal, right? So one observation, with this observation we can use the breadth first search to solve this problem. Okay, now what will be our success criteria, right? Success criteria means when we should return the minute, this final output, minute 4, when we should return this final output, right? Minute here is nothing but this is every step that we are following, right? In every step we are making all these fresh oranges as a routine. All right, this is one thing. Another thing is the success criteria. If all the fresh oranges has become rotten, then it means we need to return the final step, like these are the minutes that we need to get, or these are the basically whole minutes that will take to make all the fresh oranges a routine. So in this case 4 is the output, but the criteria, success criteria is that all the fresh oranges has become routine. In other words, fresh oranges will become 0, right? So we can, what we can do, we can count all the fresh oranges at the minute 0. So for example, in this case 1 2 3 4 5 6 fresh oranges is there, and at every step or every minute what we can do, we can keep decreasing fresh oranges because they are becoming rotten. And at the minute 4 basically all the fresh oranges are gone, or they have become as a rotten orange, right? So if fresh orange is 0, then go ahead and return the steps or the minutes, right? So this is our strategy. Now this is what we can do: store the rotten oranges to the queue, count the fresh oranges, right? poll the rotten orange and search and mark the neighbor orange as a neighbor fresh orange to make it as a rotten. Keep decreasing the fresh orange. Once fresh orange count is 0, then go ahead and return the minutes. So this is at high level, this is what we can do. Now here, because we have seen like this is like it's a breadth first search, so let's have the quickly dry run this thing. Okay, and even before dry run, let's do this as well. So let's assign couple of numbers here. What are these numbers? These numbers are basically the sequence I am just giving to the location of each orange. So this is like one location, this is 2 location, this is 3 location, this is 4, this is 5, and this is 8, and this is 9th location. Why I am doing so? So that I can store these locations. However, in the code, what we are going to store, we are going to store the coordinates x and y pair, x and y coordinates, right? But here, to understand the concept, I am just using some sequential numbers so that we can store these sequential numbers as a location, and then we can just do the dry run for the breadth first search strategy. So let's go ahead and do that. So first, rotten orange is at the first location. So we stored first or 1 in the queue. We will go ahead and poll this one here, and once we will poll this orange from the matrix or from the queue, then we will see the neighbors. Okay, what are my neighbors? So neighbors are basically 2 and 4. We will go ahead and store to the queue, and then we will mark them as a rotten orange. So this is like at the minute 0. Okay, now minute first we have the 2 size. We got the size as a 2 for the queue, right? Now we need to process, or we need to poll these 2 elements as well, because they are the rotten oranges, and that is the minute 1. Okay, so this is minute 1. Now what we will do, we will poll uh, 2. So 2 is this guy, and it will make this orange as a routine. What is this location? This location is 3. We will go ahead and insert to the queue this 3, right? And again we will poll 4. 4 is which one? 4 is this one. It will make this orange as a routine as well. And which is this location? This is at the 5th location, right? So again, I'm not going to repeat the same thing, that it cannot go left because it is out of boundary, and it cannot go upside because it is a routine orange. So it will just visit all the eligible neighbors, right? Eligible means this would be fresh orange. It should not be empty, right? So empty cell it cannot visit, right? So this is like understood. So that's why I'm not repeating the same thing again and again. Now my queue size has become 2. Now this is at the second minute, right? So now I will poll 3. What is 3? 3 is this location. It will not have any impact, right? Because it is empty cell. So empty cell, it cannot do anything in the empty cell because there is no orange here. It cannot do on the left side because it's already rotten, right? So this 3 will not have any impact on other oranges. Now we will go ahead and poll 5. 5 is this one, and it will impact this orange. So this orange is basically at the location 8. We will go ahead and store 8 location, and we will mark it as a routine. So this is our third minute situation, like this minute. Okay, now we will poll 8. We will poll 8 this guy, and it will make 9th orange as a routine. It cannot do anything in the empty cell. It cannot go upside. I mean, it can move to the upside because, but it's already rotten, so it will not make any difference. So it will only impact only at the 9th location fresh orange. So we will go ahead and store 9th location and the queue. Now we reach to the minute 4. We will poll 9th, and then we will see, okay, what is at the 9th? Its upside is empty cell and left side is already rotten, so it will not make any difference until the time fresh orange has become 0, right? Or in other words, all the fresh orange has become rotten orange, or they have become 0, or fresh orange has become 0 or rotten orange. It's the same thing, right? So once fresh orange has become 0, we will go ahead and return these steps. So in this case, if we start from 0, then it will be 4. If we will start from 1, then it will become 5. But here in the problem statement itself, it's starting from minute 0, so we will go ahead and return 4. So this is very high level dry run. Now let's convert this thing into the code itself, right? So let's do this. If grid is null, right, then what is going to happen? We'll go ahead and return -1, right? Why we are going to go ahead and why we are doing the return 1, return -1? I'm sorry. So if it is not possible, right, we return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is not possible, then return -1. So if the grid is empty, there is no orange, no fresh orange, no written orange, no empty cell, then in that case it will be written -1, because it's impossible to make all the oranges as a routine, right? So n equals to grid, this is column length here, grid 0 dot length. Okay, now what we will do, let's follow our steps, what we have to do here. So our steps were these ones, right? Store the rotten oranges to the queue and count fresh orange. So let's go ahead and do that. So we need two nested loop because it is two-dimensional matrix here. I++, similarly for loop, another for loop. This is nested for loop. J equals to 0, j is less than n, and j++. If grade ij equals to 2, what does that mean? It is a rotten orange, right? Then go ahead and insert these coordinates to the queue. Let's go ahead and do that. Else if grade ij equals 1 means they are the fresh orange, then go ahead and increase fresh orange. Fresh orange is what here? Fresh orange is one variable we can take here. Fresh orange is equals to 0. Alright, so now this first step is done. And let's say if this fresh orange is equals to 0, then what we need to return? 0. Why? Because let's say if the grid is there, but there is no fresh orange, then at the minute 0 there was no fresh orange, then we need to return still minute 0. Let's consider this example 3, right? So here is the empty cell and the rotten orange is there. So since there are already no fresh orange at minute 0, we need to return 0. So we just calculated that there is no fresh orange, then it means at the 0th minute there was no fresh orange, so minute will be 0, right? So that's why we are returning 0 here. Now what we will do, we will do BFS here. So let's do this. Let's apply the breadth first search here, and in breadth first search what we do, we check if queue is not empty, right? And then we take the size. Why we are taking the size? We can see from here the dry run that we did already. So at the first step we were having only one element, so we need to process first one element. If we are having two elements in the queue, we need to process it 2 times. If there are 2 elements, then we are processing again 2 times. If it is one element, then we are processing 1 time. If it is one element, we are processing 1 time. So whatever the size will be there for the queue at every step, that we need to iterate those many elements, and that's why we need to take the size, and we need to process those elements from the queue. So that's why we are taking the size here. I++, let's go ahead and poll from queue. So there is another difference here. For conceptually we were using 1 2 3, but here we are using the coordinates, x and y coordinates, right? So x and y coordinates means in the row and column pair, right? So for example, this first is 0 0 0 0 coordinates, and similarly other coordinates will be there in the uh, row and column manner, right? So this coordinate is 0 0, and then basically similarly we will use all the other coordinates in the matrix following these xy coordinates in the direction wise. Okay, all right. So now what is our x coordinate here? That will be at the 0th location, and byte coordinate will be at the first location, right? So location means 0th index and first index here. Okay, that's why we are doing I and j. So the I is at the 0th index and first j is at the first index. All right, once we found these coordinates, then we need to go 4 directionally, right? So let's go ahead and do that 4 directionally. So we need to take 4 direction. How we will take? 0 1 0 -1 1 0 -1 0. So on the basis of these coordinates we will move. So remember we were discussing these directions here. So let's do in this direction. So okay, so let's say this center is the 0 0 location, right? So the center is basically nothing but it is the 0 comma 0 location. And what is this location? This location is basically 1 comma 0, right? What is this above location? This is 0 comma 1, right? What is this location? 0 comma minus 1. And what is this location on the left side? This is minus 1 comma 0. Okay, so that's how we are taking all these four directions, right? So that we can just keep adding like x and y coordinates to every cell, and then we can move up, down, left and right, right? So that's what exactly we are taking all these coordinates and we will be moving like the similar way. So int direction and then directions, right? We need to iterate this directions array and we need to build our new coordinates. So let's go ahead and do that. Direction 0 and then int by equals to current by plus direction 1. All right, so remember when we were doing dry run here, we were checking that it should not go outside of the matrix. So let's go ahead and check those as well, right? It should not go outside of the matrix, and it should not be the empty cell, right? And it should not be the roten orange, right? Because roten oranges we will pick from the queue and then we will make other fresh orange as a roten, right? But we will not make roten orange as a roten. So that let's check the base condition here. So x, if it is less than 0, if it is greater than m minus 1, less than 0 or greater than n minus 1, or great x by, it's if it is already roten, right? Or if it is already blank or empty cell, then also we need to continue 0, right? 0 is empty cell. Continue means basically what it will do, it will not process, it will return from here itself and it will process for the next direction. And if these conditions are not fulfilled, means it is a valid matrix. If it is a valid fresh cell, fresh orange, then what it will do, we need to mark that fresh orange as a roten orange, right? So we will mark that fresh orange as a roten orange and then we will do fresh oranges minus minus, right? Because remember this fresh orange should be 0 to return the minutes, right? And then we will store these new locations to the queue. That's what exactly we were doing in the whiteboard, right? So let's go ahead and do that as well. Q x comma by q dot offer, store this array x and y. All right, now we need to take the minutes as well, one variable. And once this whole process is done, right, this once we process this queue at every step, right, then what we need to do, we need to increase this minutes plus plus, or this is step. Minutes is nothing here, but these are the steps. And also after each step, let's check if fresh oranges has become 0 or not, right? If they have become 0, then go ahead and return these minutes. These minutes are nothing but they are the steps. And if we did not find such match, then go ahead and return -1. So this is like our thinking and thought process. Let's quickly fix these errors. So what it's saying, q dot offer cannot find symbol. Looks like I did not have anything q, so let's declare q here as well. Q int, I think q was already there. Let's see here. So q should be here actually, right? So q int new linked list. Okay, so this is q, right? So looks like now there is no more compilation error, so I think it's compiling fine and it's returning the expected result as well. So now let's quickly check what will be the time complexity. TC means time complexity and SC means here the space complexity, right? So time complexity is m into n. M is the rows and n is the rows. So we need to traverse the whole matrix, so it will be m by n. And the space complexity also during recursion, and then we need to maintain m by n, because in the queue itself we are maintaining. In the worst case we have to traverse the whole matrix, so it will be m into n. Let's quickly go ahead and submit. here. So looks like this is working fine. Okay, another optimization what we can do here, remember here we were checking if grid is roten orange, either roten orange or empty cell. We can club these two conditions in the one condition. How we can do that? So let's go ahead and check if it is not fresh orange, right? If it is not fresh orange, if it is not fresh orange, what does that mean? It is the roten orange or empty cell, right? So here we can see here, right? So these are only three values, right? So we can use this condition, right? So either it will be 0 or 1 or 2. So if it is not 1, means either it will be 0 or it will be 2, right? So that's what we are checking. So we just did the clubbing of two conditions rather than checking two conditions. Let's go ahead and use only one condition. Let's quickly check for the compilation errors, and let's go ahead and submit. So see the runtime. So basically it increased a little bit. So this is like minor optimization, we can do that. Okay, so this was the code with this approach, whatever we discussed. Before wrapping, very quick recap here. This is like grid we have been given, and with this grid basically there are three values that we have been given: 0, 1 and 2. 0 means an empty cell, 1 means as a fresh orange, and 2 is a roten orange. What is happening? Every minute every roten orange is making other fresh orange as a roten, right? So what we have done here, what we have observed and done here, we are storing fresh orange to the queue and then polling that fresh orange from the queue, and then after polling then we are going around, we are checking all the four directionally, right? And after going four directionally, basically we are checking if there is any fresh orange or not. If there is any fresh orange, then in that case what we are doing, after checking if it is a frost orange, we are making them as a roten, right? And that's what we are exactly doing in the our algorithm, right? That's what we are doing in our algorithm. And for the success criteria, we already pre-computed fresh orange earlier. If the fresh orange is there, right, there are, if there is no fresh orange, then we are returning 0 minute, because at the 0th minute there was not any fresh orange, right? And if there is any fresh orange, then at every traversal we are decreasing this fresh orange here, right? Once we are moving around and we are just checking they are fresh orange, once we are marking them as a roten, it means we are decreasing those fresh oranges, right? Once with all the steps, if fresh orange becomes 0, then we are going ahead and then returning our steps. So steps here are nothing, but here this is like one step, this is second step, this is third step. Whatever our size is there of the queue, that is becoming our one step, right? So that's what exactly we are doing here. One step means like going through this queue at every iteration, right? So this is one step, and after every step we are incrementing our step. So here is step or label is minutes here, right? And then once press orange is 0, then we are going ahead and returning those minutes as well. So hopefully this is useful. Thanks a lot. Have a good one. Bye.